On right? Straight, yeah. The small one. Mhm. Okay, good morning again. I guess we will begin. Um, are you all hearing me? Just want to be sure. Miss Pratt, Miss Fernanda, can you hear me?
Yes, sir.
Okay,
Yes.
all right. Okay, all right. Thank you. Yeah, I think Miss LaRochelle said she can't make it, and I've heard from Miss Nairn, so we can begin at this time. Okay. So today we are continuing with chapter 6. We're going to try to see if we cover another 2 sections, and we are looking at some additional topics in algebra. I didn't see any homework from the last class. Nobody sent homework. If you did it, you need to take a picture, send it to me so I can see, give you credit for having done it. And I don't know if you have any questions regarding any of the homework, but if you did do it, please send it to me so I could give you credit for having completed it. All right, so we have section 6.2, which we want to look at, and 6.3. 6.2 deals with equations, and 6.3 is continuing with equations, but with problem solving using equations. We're starting on page 317 of the text, if you have the book. And it starts off with some definitions. Okay, so you will see the term, they use the term linear equation in one variable. Okay, and we will be looking a little later at this whole concept of linear equation, because linear, what word do you see contained in this word linear? Give me one word you could see right away that's contained in the word linear. Miss?
Line.
Line, right. So a linear equation, when we're going to be looking at drawing graphs of equations, I think in the next chapter 7, I think it is. Yeah. So in chapter 7, we're going to be looking at drawing graphs of the equation, and a linear equation produces what is called a line graph, which is a straight line graph. And so that's why it is referred to as a linear equation. Then we have some equations which produces curves instead of a straight line. And one of the equations that produce curves is your quadratic equation. So we'll be looking at a little bit on that later on. But the linear equation, apart from producing a straight line, the equations that we're looking at in this section have one variable. Okay, now we're using the term x here, but it doesn't have to be x, it could be any letter in the alphabet. We do have equations with more than one variable. Okay, and I don't know if you remember doing simultaneous equations or equations with 2 variables. we'll also be looking at that a little later. But for today, the focus is on linear equations with one variable, and where in this case, they have the format of the equation, ax plus b equals 0. So it is saying that a and b are real numbers, and a cannot be 0, because if a is 0, then it means that this portion here would end up being 0, because any number times 0 is 0. So anytime you're looking at a linear equation, you're going to have some number, some real number times a variable plus some constant equal to some value. Okay, so I think most of you should basically have some idea how to solve equations. Okay, so the intent of solving equations is to find the value for the variable that makes the statement true, and we refer to the value as solution or roots to the equation. So sometimes you will see where they ask you to find the solution of an equation, solve the equation, or find the roots of an equation. All are asking the same thing, to find the value for the variable x, or whatever the variable is, to make the statement true. Once you find the variable, then if you substitute it into the equation, then it should produce a true statement. And then it says here, equivalent equations have the same solution set. So if two equations have the same solution, we refer to them as equivalent equations. Now, in this page 318, they make reference to addition and multiplication properties of equality. Now, I think we did this when we were doing some other properties of numbers. It says the same real number or algebraic expression may be added to both sides of an equation without changing the equation solution set. So you see here where it says A equals B and A plus C equals B plus C are equivalent. So all they did here, they started off with A plus B, but now we just add C to A and we add C to B. So if you add the same thing to the two sides of an equation, it doesn't change the equality of the equation. That's basically what this is saying. Once you add the same thing to both sides, your equation equivalents remain the same. And the same applies when we are multiplying. So if you have two if you're saying that A is equal to B here, if you multiply A by some other number, in this case C, once you multiply B by that same value, the equality of the equation remains. Doesn't change the equality. So we know, because we know this, we can use those properties to help us when we are solving the equation. Okay, so on page 318, you'll see a table at the bottom of the page, which is using those properties that we just mentioned. So you have this simple equation here. It says x minus 3 is equal to 8. So it's, if you remember, when we solve equations, sometimes we use what is called the opposite operation. So this is saying subtract 3. So you're going to have to add 3. But if you add 3 to this side to cancel out the 3, you have to add 3 to the other side. So this is showing you the equality. If you add the addition property of equality, if you add 3 to both sides, it does not change the quality of the equation. So if you add 3 here, it cancels out the 3, and you add 3 to that, you get 11. So x is equal to 11. And same here, you have x plus 7 equals negative 15. So the opposite of add would be to subtract. If you subtract 7 from the left-hand side, you subtract 7 from the right-hand side, okay? It will not change the equality, so you could use that to help you solve the equation. In this case, x is equal to negative 22. And likewise, with multiplication, okay, this is multiplication. If you have 6x equals 30. The opposite would be to divide by 6. Once you divide both sides by 6, okay, then it doesn't change the equality. So you end up with x equals 5 in this case. And then lastly, you have a division here. X divided by 5 is equal to 9. So therefore, if you want to solve this, you can do the opposite, which is multiply. So if you multiply both sides by 5, this 5 cancels that 5, and then 5 times 9. So 5 cancels 5, you leave with x, and 5 times 9 is 45. Okay, this table didn't put the multiplication sign in. Okay, and then this table here in your book, this should be 1/6. Okay, they didn't put the 1/6 here. This should be 1/6 right here where you see this z, and then there should be a multiplication sign here. So if you have the book, you will see the multiplication sign, which they have it as a dot, and then this should be 1/6. Okay, so that is using the properties of equality to solve equations. And so we move on to page 319, where they actually, in this case, we were looking at equations with just one operation. All we had here was subtract, add, multiply, divide. Of course, equations may have more than one operation, like this one. It says 2x plus 3 equals 17. We want to find the value of x. So the first thing we do is to isolate eliminate the 3. So the opposite of adding 3 would be to subtract. So if you subtract 3 from both sides, you're going to end up with 2x equals 14. Then this is a multiplication, so the opposite would be to divide. So you divide both sides by 2. So that gives you x equals 7. And it's always useful to check your answers. And so you could check it by putting 7 in place of x in the equation. So this is the equation you started off with, 2x plus 3 equals 17. So if you put the 7 in place of x, 2 times 7 plus 3, okay, 2 times 7 is 14, 14 plus 3 is 17, 17 equals 17, which is a true statement. So because this is true, it means then our answer is correct. So whenever you solve an equation, you could always check your answer to see if your answer is correct by substituting the answer you get into the equation. And once you get the two sides to be equal, then you know that your answer should be correct. Okay. So I'm going to ask you now to use that same principle we looked at just now to solve an equation. Give you a minute to work on this one. Okay, Miss Fernanda, and what you did for this?
Okay, I have 4x plus 5 minus 5 equals 29 minus 5.
Mm-hmm.
And then 4x equals 24. Then I say x equals 24 divided by 4. And then x gives me 6.
Mm-hmm. And did you check to see if the answer is correct?
I didn't get to that part yet.
Okay, so if we want to check it, so we'll just put 4 times 6 plus 5 equals 29. They usually put a question sign here because we're not sure. So we're going to check. 4 times 6 is 24. 24 plus 5 was 29. 24 plus 5 is 29. So 29 equals 29. So this is our check. Now you don't have to actually show the check, but it's always good to do it roughly just to see if your answer is correct.
Okay.
Okay. Okay. So that was a simple two operation equation. Of course, equations can be a little more involved. So on page 319, they give you the steps for solving linear equation. Okay. And it says simplify the algebraic expression on each side by removing grouping symbols and combining like terms. So sometimes you do have brackets. And so it's advised to deal with the brackets first and then combine the like terms. And then you collect all the variables on one side and all the constants on the other side. Then you isolate the variable and solve, and then you check your answer. Okay. So basically, that's what we did somewhat. It's just that in this one, we didn't have any brackets, but we did end up with the variable on one side, which is the 4x, and the constant, which is the 24. And of course, a constant is a number without the variable on the other side. Okay. But like I said, this is a basic one. So we're going to look at one now, which involves a little more than that example. So in this second example, you are asked to solve 2 times x minus 4 minus 5x equals -5. So here we have a grouping, we have brackets. So before we can begin to solve, we have to deal with the brackets. Okay, so this is the equation we're given right here. So to remove the brackets, we're going to distribute the 2. We're looking at the distributive property. 2 times x is 2x. 2 times minus 4 gives you -8. Then we bring the -5x down, equals -5. So the distributive property was used to remove the brackets here. So now that we have removed the brackets, we could bring the like terms together. So it's 2x minus 5x gives you -3x, and then -8 equals -5. So you combine 2x and 3x, sorry, 2x and 5x to get -3x. 2x minus 5x gives you -3x. So once we do that, now we can deal with the moving of the -8. Okay, so the opposite of -8 would be +8. Okay, so you're going to add 8 to both sides. So once you add 8 to both sides, this -8 plus 8 will cancel this out. So you're going to just be left with -3x. And then -5 plus 8 gives you 3. So -3x is equal to 3. We're going to continue then. And so since this was a -3 times x, the opposite would be to divide. So we divide both sides by -3. So that -3 cancels out that. And then 3 divided by -3 gives you -1. So x is equal to -1. And so you could always check your answer to see if it will give you a true statement. So what they did is to put -1 in place of x. So this is what you were given. So you put -1 here where the x was. You put -1 here again where the x was. So -1 minus 4 is -5. And 2 times -5 is -10. Okay, so that's -10 minus, and then if you put 5 times -1, you will get -5. Okay, then -10 minus -5 gives you -5. So -5 is equal to -5, which is a true statement. So once you get a true statement, then you know that your answer is correct. So the answer is x is equal to -1. Okay. So I want you to look at this one. Go ahead and try this one. Checkpoint 2. Oh, Miss Nairn, you're here. Good morning.
Good morning.
Okay. Okay, Ms. Pratt, tell me what you did so far. Ms. Pratt, you with us? Ms. Pratt. Okay, Ms. Nairn, can you tell me what you have so far?
Okay, I just came on, so bear with me.
Yeah,
So I have 6x minus 18 minus 10x equal -10. Then I group them together, so I get -4x minus 18 equals -10.
Okay.
And then should I be adding 18 on the two sides?
Okay, -4x minus 18 plus 18 equals -10 plus 18. Okay.
Right. And then that would be -4x -4x equals 8. Is that right? Okay. And then after that, I will say -4x over -4. is equal to 8 over, is it 4?
The same thing you have here, you have to do the same thing on the other side.
Oh, so that'll be, okay, so -4.
Mhm. Okay. So to keep the equality of the equation, whatever you do to one side, you have to do to the other. So if you divide by -4 here, you have to divide by -4 on this side. Okay, so once you do that now, what's the next step?
Okay, so then it'll be, would it be -2x?
Okay, when you cancel out this, what do you get right here?
1.
One what?
Or x?
Okay, so it's just 1x or just x. You don't have to put that. Equals. And then when you divide the 8 by -4,
2. -2.
-2. Right, so x equals -2. All right. And you could always check your answer by substituting the -2 into the equation and see if you get back a true statement. But this is the answer right here, that x equals to -2. So if you want to check it, put in 6, open brackets, -2 minus 3 minus 10 times -2 equals -10. So that -2 and -3, -3 will give you -5. 6 times -5 is -30. Oops. And then minus, then 10 times -2 is -20 equals -10. And then -30 minus -20 is the same as -30 plus 20 equals -10. So that -30 plus that gives you -10 equals -10. So you get a true statement. So it means then that the answer of -2 is correct. Now, of course, when you have a test or exam, you may not have as much time to go and do a full check, but it's always good to do a rough check to see if your answer makes sense. Okay, so that's your second checkpoint there. Okay, so on page 320, you'll see this study tip, which I think is useful to be aware of, that there's a difference between simplifying and solving. Okay, so there are times when persons make the mistake and try to solve an expression. Right here, this here is an algebraic expression. Why is this not an equation? Everybody could see this. Why is this? I'm going to circle it. Why is this not an equation? What's missing?
There's
The
no
sum
equal.
factor.
I didn't hear you. Why is it not an equation that which I just circled? Are you
I
able
was
to see?
saying the equal, there's no, you know how you have the equal sign
Yeah.
and included.
Right, there's no equal sign there. So we don't have an equation there. Okay, so this is just, this first one is just an algebraic expression. So when you have an algebraic expression, the most you could do in an algebraic expression is to simplify it by bringing the like terms together. So when you finish this, what you got for this one, you don't get anything to say x equal. You just reduce it to the lowest term, simplify it as far as you could go. Now with an algebraic equation, you see an equal sign, at the end of solving, you're going to say what the variable is equal to. In this case, x is equal to -12. So please note the difference between an expression and an equation. An equation tells you that one set of things is equal to another, and at the end of solving an equation, you find out what the value of the variable is. When you have an algebraic expression which doesn't have the equal sign, the most you could do is try to simplify it as far as you can, and that's it. But you don't end up saying that x is equal to any value because it's not an equation. Okay, so moving on then, we have we have this equation that has variables on the two sides. And so basically, we follow the similar procedures before. Because we have a variable on the right as well as on the left, we're going to have to reorder so that we have all the variables on one side, all the constants on the other side. So what they have done here, they have moved the 8x over to the left-hand side. Of course, because of that, the sign changes. Okay. And then they have moved the 12 over to the right-hand side. Okay, so it becomes, since it was a subtract 12, it becomes plus 12. Okay, now the way they set it up here, I guess some persons may not choose to do it that way, but this is from your book, page 321. So sometimes as a shortcut, we say 5x minus 12 equals 8x plus 24. So we could go straight ahead and say 5x, and we want to move the 8x over. So you bring it to the other side of the equation. So you're going to have to do opposite operation. So that becomes minus 8x. And then the 24 remains where it was. And then you're going to bring the 12 over. So you're going to have to do the opposite operation. It was minus 12. So you're going to do the opposite, which would be plus 12. So you could do that transfer straight away, bring all the variables to the left and all the constants to the right. And then 5x minus 8x gives you minus 3x equals, and then 24 plus 12 is equal to 36. And so now we want to find x. So we're going to have to divide both sides by minus 3. So if you divide this side by minus 3, you're going to get x equals 36 divided by minus 3, x equals negative 12. Okay, and so that's the answer we have here, but they have it set out with a little bit more detail in the working. And then they do the check at the bottom here to see if you could get a true statement when you substitute the negative 12 into the equation. Okay, so if you want to, you could set it out fully by doing your negative 8 here, sorry, negative 8x, negative 8x. Then once you simplify that, then you do add 10 to 12 to both sides. Then you end up with negative 3x equal 36. Then you divide both sides by negative 3. And then you find the value of x, in this case, which is negative 12. But you could go straight away and do your transfers. Just remember, the opposite operation would apply once you move over the equal sign. So what was a positive 8x when you move over becomes minus 8x. What was a negative 12 when you move over becomes an add or positive 12. And then you simplify it from there. So I'm going to ask you to look at this one and try it. You could do the long method, or you could do the short method that I just displayed. Give you a minute to do that one. Okay, Ms. Fernando, tell me what you did, what you have done so far.
Okay, so far, okay, I have 2x minus 8x plus
Mhm.
9 minus 9 equals negative 3 minus 9. Oh, gee, yeah, I didn't jack up.
All right, let me start over. You said
No, sorry, no. Yeah, that's right.
2x.
2x minus x minus 8x
Mm-hmm.
plus 9 minus 9 equals negative 3 minus 9.
Mm-hmm.
Then 2x minus 8x equals negative 12.
2x minus 8x.
Equals negative 12. And then the next line, I worked out the x
Okay,
function
2x minus 8x
equals
equals
negative 12.
12. Mm-hmm.
And then now I have negative 6x equals negative 12.
Mm-hmm.
And then negative 6x divided by negative 6 equals negative 12 divided by negative 6.
Mm-hmm.
And then x equals 2, positive 2.
Okay. All right. That looks right. Yeah. Okay. And if you want to check your answer, then you'd say 2 times 2 plus 9 equals 8 times 2 minus 3. 2 2's 4 plus 9 equals 16 minus 3. 4 plus 9 is 13. 16 minus 3 is 13. So that's a true statement. So therefore, x is equal to 2. So this would be your check. Okay. Now, you could shorten your work by saying 2x minus 8x equals minus 3 minus 9. So that gives you negative 6x equals minus 12. So x would be equal to minus 12 over minus 6. X equals 2. Or you could shorten it that way by doing the transferring of the 8 over to the left hand side, to 8x, and then the 9 over to the right hand side. So you do the two transfers at the same time, and then you simplify and solve for x. Okay. All right. I don't don't think I'm not gonna go through this one with you. It's on this slide. I'm just gonna go straight to the checkpoint, let you try that one, because yeah, you should be able to tackle this. So I want to try work on this. Give you a couple minutes to do that one. Okay, Miss Nairn, right now it's only two of you. I think Miss Pratt said something about the internet. So I'm gonna ask Miss Nairn, tell me what you did so far.
So I did, so I got 8x plus 4 equals 29 plus 6x minus 15.
Mm-hmm.
And then 8x minus 6x is equal to 29 minus 15 minus 4.
Mm-hmm.
Then again, negative 2x is equal to 10.
Why you say minus 2x? This is
Oh,
8x
sorry.
minus.
It's just 2x.
Mm-hmm.
2x is equal to 10.
10, okay, 29 minus 19, okay, equals 10, okay. Mm-hmm.
And then 2x over 2
Okay.
equal to 10 over 2
Mm-hmm.
equals x is equal to 5.
Okay, thank you. All right. So we could check it by substituting, but I'll skip the check now, but the working is correct. Of course, in the book, they have a more drawn out, more involved working, but you could shorten it as Miss Nairn did just now. Yeah. Okay. Very good. Okay, so the next section then, which is on page 322, we are looking at equations involving fractions. Okay. So So the equations without fractions are easier to solve, but when you have fractions, basically the same principle with adding or subtracting fractions could be used here. So in this case, we have 3x over 2 equals 8x over 5 minus 4. Okay. So in order to solve this, we need to eliminate the denominators. And so we try to find a number which both of those denominators can divide. And so for 2 and 5, you will see that they chose to use 10. All right. So the denominators are 2 and 5. The smallest number that is divisible by 2 and 5 is 10. You could use a bigger number like 20 or so, but you just end up with more working. So that's why it's good to find the smallest number that is divisible by 2 and 5, which would be the lowest common multiple. All right. So it says we begin by multiplying both sides of the equation by 10. So what they have done is to multiply the 3x over 2 by 10 and the 8x over 5 minus 4 by 10. Okay, so if you do the canceling here, this is really 10 over 1. So 2 into 10 is 5. 5 times 3 is 15. So that's how they get the 15x here. All right, and then here, you're going to have to do 10 times the whole of this side. So if we do just this portion first, 5 into 5, 1. 5 into 10 is 2. 2 times 8 gives you 16x. And then 10 times 4, well, 10 times negative 4 is 40. That's minus 40. Okay, so 15x is equal to 16x minus 40. And so once we have this portion now, we can bring the variables to the left, keeps the constants on the right. So 15x minus 16x is equal to 16x minus 40 minus 16x. So we're subtracting the 16x from both sides. So you end up with negative x, because 15x minus 16x gives you 1x, negative 1x equal to negative 40. Now, when we are solving for equations, we don't solve for negative x, we solve for x. So since this is negative x, and remember negative x is the same as negative 1x, okay, the coefficient is 1. So you're going to divide both sides by negative 1. And so it ends up being negative x divided by 1 gives you positive x, and negative 40 divided by negative 1 gives you 40. So our answer is x is equal to 40. And let me see if they have the check here. Oh, they didn't give a check, but you could always check your answer by saying, okay, 3 times 40 over 2 equals 8 times 40 over 5 minus 4. 3 times 40 is 120. 120 divided by 2. 8 times 40, that's what? 320 over 5 minus 4. So 2 into that goes 60. And 5 into 320, that's 5556. That's 64. Okay, 5 into 5. Okay, 5 into 320 is 64. So that's 64 minus 4. So 60 is equal to 64 minus 4 is equal to 60. So that's a true statement. So therefore, your answer of x equal 40 is correct. All right, so look at this one. What would be the LCM for this one, 3 and 2?
6.
6. Okay, so I want you to use the 6 then and simplify, solve this equation. Okay, Ms. Fernando, tell me what you did so far.
Okay, so far, I was just getting
Mhm.
ready to finish it up. 6 to 6. I guess I'll say times 2x divided by 3
Mhm.
equals 6 times 7 minus x divided by 2.
Mhm.
And then my next line is the 2 times 2x over 1, because I cancel out the 3 and the 6. It goes into 3 goes into 6 2 times, so I put 2
Mhm.
equals 3x divided by 1 minus 42. Or it would be
Okay. The
the other
42
way
came,
around.
yeah, 42.
42
Mhm.
minus x over 1 divided by 1.
Well, when you divide when you cancel out the 2 on the 6, what you get?
When I cancel out the 2 and the 6, I get 3.
Okay, so that should be 3
Mhm.
times. Yeah. So 2 times 2x gives you.
Pardon? Oh,
Mhm.
so,
Next line.
okay, the next line is 2x divided by 1.
Um, I thought you said you have 2 times 2x here.
Yeah.
So 2 times 2x gives
Oh,
you
so
what?
we're going to multiply it now. Okay, so that's where I stopped.
Mhm.
So
So
I
what
would
is,
say 2 times the 2x, that'll give me 4x.
okay, so 4x equals 42 minus 3 times x is
3x.
mhm.
Now, my 42, wouldn't it be negative or wouldn't be negative? No,
Why would it be negative?
I don't know why I have it as negative. I probably
Six,
made an error. Okay,
6 times 7
it's a
is
positive,
42.
yeah.
That's a positive 7.
Mhm.
Okay, so what's the next step here then?
Okay, so now next step will be 4x plus 3x.
Mhm,
And then that equals 42.
mhm,
So that's 7x equals 42.
mhm,
And then 7x divided by 7 equals 42 divided by 7.
mhm.
So now x equals 6.
Okay, thank you. All right, x is equal to 6, and you can always check by saying, okay, 2 times 6 over 3 equals 7 minus 6 over 2. So we put the 6 in place of x. So 2 6s are 12 over 3 equals 7 minus 6 divided by 2 equals 3. 3 into 12 is 4, and 7 minus 3 is 4. So we get a true statement. So therefore, x equals 6 is correct. Okay. All right, so that was Mr. Nanda. Okay. All right, so now we gone into some of the applications of equations. And in the last class, we mentioned about formulas and modeling. And so this is one of those questions where we are looking at models that we use to derive formulas. So it says in the section opener, okay, we introduce line graphs, and then what the graph that they mention is repeated here, 6.2, indicating that persons who with a low sense of humor have higher levels of depression in response to negative life events than those with a high sense of humor. So now this is not an exact science, but what they are trying to suggest here is that people with a high sense of humor do not react as negatively to negative life experience as people with a low sense of humor. So what they did is to draw a graph. So this red line is showing you high humor group, so the people with a high sense of humor. And then this other one here, this blue line is showing you the people with a low sense of humor. And then, so it says here on this side, groups average level of depression in response to negative life events. So you'll see this side, this vertical axis. You will notice that the people with the low humor group, their graph is more steep. It rises more quickly. Whereas the people with the high humor group, their line doesn't rise as much. Okay, so they're suggesting that the people with high sense of humor, they do not react as much to negative life events as people with low sense of humor. They react more severely based on the the angle at which this line is. So now they have these two formulas that they use here. They have two formulas. So this formula says for low humor group, D is equal to 10 over 9x plus 53 over 9. And for the high humor group, D is equal to 1 over 9x plus 26 over 9. In each formula, x represents intensity of the life event from low, which is 1, to 10, which is high. And D is the average level of depression in response to the event. Okay. So this axis here is showing you the level from low, from 1, 10 is high. And then this axis here is showing you the the level of depression. Okay, so now they ask you now, if the high humor group average a level of depression is 3.5 in response to a negative life event, what is the intensity of that event? How is the solution shown on the red line graph? All right, so the question asks you, again, let me read here. If the high humor group, that's the one in red, average level of depression is 3.5 or 7 over 2 in response, of course, 3.5 in fraction form is 7 over 2. So it's the same thing. In response to a negative life event, what is the intensity of that event? How is the solution shown in the red line? All right, so because we have two formulas, one for low intensity, for low humor, one for high humor. The question asks about the persons in the high humor group. So this is the formula we'll be looking at then. Okay, and they tell you that the average is 3.5. So basically then we're going to be using that formula for the high humor group, which is D equal 19x plus 26 over 9. And they tell us what the average is. And remember, D is supposed to be the average. So they tell you the average is 7 over 2. So basically, we're going to be substituting. We're going to put 7 over 2 in place of D. So we're using the high humor group formula. We're putting 7 over 2 in place of, and then we're going to work out what X is. Okay? And remember, it says X represents the intensity of the life event, the negative life event. And you're asked to actually work out what that is. So basically, we have three fractions here, 7 over 2, 9x, 26 over 9. So the lowest common multiple for the 2's and the 9 is 18. So you're going to multiply by 18. 18 times 7 over 2. 18 times these 2. So when you cancel this out, 2 into 18 is 9. 7 9's 63. And then 9 into 18 is 2. So 2 times 1 is x, so that gives you the 2x. 9 into 18 is 2. 2 times 26 is 52. All right, so when you do all these calculations here, this is what you're going to end up with. 63 is equal to 2x plus 52. So we're going to go on to the next slide now. So based on what we have here, we can now move on. We're subtracting 52 from the two sides. Okay, so you end up with 11 is equal to 2x. So if you want to find x, you're going to have to divide both sides by 2. So 11 over 2 is equal to x. All right, so the formula indicates that if the high humor group averages a level of depression of 3.5 in response to a negative line, the intensity of that event is 11 over 2 or 5.5. And this is illustrated in the line graph for the, okay. So we said that the situation for them was 3.5. So the level of depression is 3.5. So if you look here, this is 2, this is 4. So 3.5 would be roughly a little below 4. You go straight across the line and you come down and you get 5.5, which is what the formula gives. So that's how we're going to show on the graph the relationship between those two numbers we got. So we got level of depression of 3.5. And from the graph, we could show that according to the graph, the intensity is 5.5. So in a case like this, we can either solve it using algebra, or we can use the graph that's given to you to work out the level of intensity. So it's a little complicated, but it is applying some of the basic principles of algebra to real life situations. So we're going to look at this. Oh, this is okay. So now this one is saying, use the model for the low humor group, given in example 6 on the previous page, to solve this problem. So it says, if the low humor group averages a level of depression of 10 in response to a negative life event, what is the intensity of the event? So we're going to use the other formula, the one for low humor group. It says the level of depression is 10. So you could almost kind of guess your response, because we're doing the low humor group, and this is the line for that group. The level is 10. So if you go straight across from 10 to the blue line and come down, can you give a rough guess as to what the intensity is? Ms. Nairn?
Okay, so I go in from 10
To
and come,
the blue line and then come down.
okay, so that's 3.
It's somewhere between 3 and 4.
Yeah, like 3.5 or 3.
Yeah, it could be around that. So what we're going to do then, we're going to use the formula for the low humor group. So that's D equals 10 over 9x plus 53 over 9. We're going to put the 10 in place of D and try to work out what x is. And you should get something close to 3. So I'm going to leave you to do that for a minute or so, at least start the process. So we're using this one to answer this question. So we already know the level of depression is 10. So we're going to use the low intensity, the low humor group formula to work out what the intensity of the life event should be if the level of depression is 10.
Ms. Allen, I have a question.
Hello?
Ms. Allen, you can hear me?
Yeah.
Okay,
Repeat the
so
question.
I said I have a question. So because the two denominators are the same, there is
Mhm.
no need to find the lowest common because they're the same. So we just calculate the equation,
Well, the lowest is 9.
right? Oh, okay.
Mhm. So you're gonna use 9. Okay, so let's look at that. Miss Nairn. Miss Nairn is gone.
I think it's just us, but I'm lost. I mean, not lost, but I'm trying to.
Okay. Okay. All right. So okay, so the formula for the low is D equals 10 over 9 x plus 53 over 9. Okay, and they tell you that in this case that the level of depression is 10. Okay, so
Mhm.
basically you're going to put the 10 in place of D, because D represents the level of depression, as 10 over 9x plus 53 over 9. So what is, we need to now solve for x, but
Okay.
we have fractions here. So what's the common denominator we're using?
18.
Well, why are you going to use 18?
Good. We're
Because,
looking at the nines, right?
yeah, but the nines
Oh,
could,
we can use 9.
you could use the nines, yeah.
Yeah.
Mm-hmm.
So that would
So,
be. So that would be. So since we're using 9, we would say 10
It'll be 9 times 10
Mhm.
equals 9 times 10 over 9x plus 53 over 9. Okay. So 9 times 10 is
90.
mhm. And then when we deal with this aspect of it,
We have to multiply everything in the bracket by the 9. So we would have to
okay.
say
So you cancel that out. It's 9 into 9 is 1, and 1 times 10 would give you
10.
10x. And
10.
then that
X.
9 and cancels again, 1. So that's plus 53.
53.
Mhm. All right.
And then we'll have to bring over the 53. So we say 9 minus 53.
90 minus 53
Oh, yeah, 90. Sorry. 90 minus 53
equals
is
10x.
10x.
Mhm.
And so then that will be 43. I mean,
Equals
sorry, 37.
how much?
37
Okay, 37 equals
equals 10x.
10. Mhm.
So then 37, we would divide that by 10,
Mhm.
and then 10x divided by 10 to cancel it out. And
Mhm.
then that would be, can we get a decimal? 3.7.
Yeah. Uh-huh.
Okay,
Mhm.
so 3.7 equals x.
Mhm. Okay. And if you look at the graph, when you go over from 10 to the graph, okay, it looks kind of like 3.5, but the more accurate from the formula is 3.7. But if you go down, you know it falls somewhere between 3 and 4. And so the graph could give you a rough idea of what it should be, but the formula would be more accurate. Okay. So
Okay.
right away from the graph, you could see that your answer, you're on the right track with the result. 3.7. Okay. Okay. Miss Nan, you followed? I think you got missing for a bit.
Yeah, I got disconnected, but yes, I follow.
Okay. All right. All right. So it's a kind of unusual formula, but that's one example of the type of modeling you sometimes have to do for certain real life situations. And so it's not an exact science per se, but it is one of those things that certain, what they call behavioral scientists, have to do from time to time to try and predict certain behaviors. All right. So in the next section then of that same section, we're looking at proportions. So we should have learned a little bit about ratio some time ago. The ratio compares two or more quantities, okay? So they give an example here. A group may contain 60 women and 30 men. So the ratio of women to men could be simplified as 2 to 1, okay? But when we are talking about proportions, we are actually looking at two ratios. It could be more than two, but at least two. All right. So a proportion states that two or more ratios are equal. And when we know that we have ratios that are equal, we can sometimes use that principle to help us to solve certain types of equations or situations. So one of the methods that we often use is referred to as the cross product approach, the cross product principle for proportions. So you'll see this here. We have 63 over x is equal to 7 over 5. So we end up with two fractions there, but one way to solve these type of proportional, when you have one fraction equal to another, is to do what is called a cross product. So we multiply. So in this case, you multiply the 7 and the x to get 7x, and the 63 and the 5. Okay, so once you do that, 63 times 5 gives you 315. 7 times x gives you 7x. And once you do the cross products, then you can solve for x. So you would say x then would be equal to 315 divided by 7, x equals 45. So this cross product is one approach we can use, and we could always check our answer by substituting the answer into the equation. Okay, and so that's another example here. Now we have this one where you are given 20 over x minus 10 equals 30 over x. Now this cross product only applies when the two sides are fully fractions. Okay, so let me see if I could look at another type of equation, because we mustn't confuse that with let me see, there's one that we looked at earlier. So this equation that we have here, even though it has fractions on the two sides, the right-hand side has a fraction and a constant. So the right-hand side is not fully a fraction. So we cannot use the cross multiplication method here, because this side is not fully a fraction. It has a fraction plus a whole number. Okay, so that cross product principle is not applicable for this type of equation. It's only applicable when the two sides of the equation are fully fractions. So let's go back to the next example we're looking at. So you see here, this is a fraction, that's 20 over x minus 10. 20 is the numerator, x minus 10 is the denominator. Here, 30 is the numerator, x is the denominator. So both sides are fully fractions. So now you can use your cross multiplication method, and this 20 times x, so that's how they get this 20x here, and then 30 times x minus 10, and that's how they get that here, 30 times x minus 10. So once you do that, then you could go ahead and remove brackets. Now 30 times x is 30x, 30 times 10 gives you 300. So 20 equals to 30x minus 300. So they brought the 30 on the left-hand side. So 20 minus 30x. Okay, you subtract the 30x here, so you end up with negative 10x equals negative 300. Negative 10x, so you divide both sides by negative 10. So x equal to 30. So the solution is 30. And you check your answer to see if it makes a true statement. And they got 1 equal 1, which is true. So that means the 30 is correct. Okay, so let's look at these two. So Miss Fernanda, no, Miss Nairn. Miss Nairn was missing for a bit, so let me call on you. Let's look at that first one.
Okay, so we're gonna cross multiply. So we're
Mhm.
gonna say x multiplied by, that'll be 2x
2x.
is equal,
Yeah, go ahead. 2x equals.
yeah, 2x is equal to 10 times 3, which is 30.
Mhm.
And then we're going to say x is equal to 30 divided into 2.
Mm-hmm. X
and x equals 15.
15, right. Okay, thank you. So because the two sides are fully fractions, okay, you're not adding these to anything or subtracting anything from them, then you could go ahead and do your cross products and solve for x. All right, so the next one is also a case where you have two fractions on either side. So you're not adding this to anything. You have 22 as your numerator. Your denominator is 60 minus x. And then on this side is 2 over x. So we have a fraction on the left and a fraction on the right. So you could do your cross multiplication here also. So Mr. Nairn, tell me what you would do for this second one.
Okay, so for the second one,
Mhm.
you say we could do cross multiplication here as well. So it'll be 60. Ugh. Do I treat x as 1 and say 60 minus x is 59?
No, you can't do that.
Okay, so
What you going to multiply? We're looking at multiplying. We cross.
I'm multiplying the 60 times 2.
You're going to multiply the 60 minus x, the whole of that.
Oh, okay. The 60 minus x times 2
Right.
is equal to 22x.
Mm-hmm. Right. Okay.
And so then we're going to say 2 multiplied by 60.
Mm-hmm.
So then 120
Mm-hmm.
minus 2x equals 22x.
Mm-hmm.
And then we're going to say negative 2x plus 22x. No, minus 22x
Mm-hmm.
is equal to negative 120.
Mm-hmm.
And then that would be negative 24x is equal to negative 120.
Mm-hmm.
And then you say 24x over 24 is equal to 120 over 24.
Now, your what's in front of the x?
Negative.
Negative 24. So
Right. Also, it'll be over. Will it be over negative 24?
Right. Mm-hmm.
So then that would be x. X is equal to 5. Yeah.
Mm-hmm. Right. X equals 5. And you could always check your answer. You could say 22 over 60 minus 5 is equal to 2 over 5. All right. So 60 minus 5 is 55. So you're gonna have 22 over 55 equals 2 over 5. Now, what number could divide 22 and 55?
11.
11. So 11 into 22 is 2. 11 into 55 is 5. Okay. So we get 2/5 equal 2/5. So that's a true statement. So it means that x equals 5 is correct.
Mr. Allen, quick question.
Yes.
Okay,
Mhm.
I got the same answer. However,
Mhm.
I worked it out differently. I didn't have negative 24 and negative 120. My answers were positive, probably because I did it on an opposite side.
Yeah, you
Would we
could do that.
be in the exam?
So-
Would we get points off for like different?
No. It's still right because you could have done the 22x first. So you could have
Mhm.
said, so let me start it here. So you could say 22x, and then you could have equals 2 times 60 minus x. So 22x would be equal to 120 minus 2x. That's what you did, huh?
Yes.
Okay. So
Mhm.
you would have now 22x plus 2x equals 120. So 24x equals 120, and you would get your 5. So x would be 120 over 24, which x equals 5. So it all depends on how you do your multiplication. So the person who did it the other way, they'll end up with some negatives, but when you cancel out, it will become positive because you are dividing by 2 negative numbers. So which would give you a positive result. So it's the same result. So
Okay.
both ways will give full marks. Okay. All right. So that method then that we were using is for when you have proportions, and like I said to you, that only applies when you have two sides of the equations are fully fractions. So you can't use that method if a portion of it is not a fraction, if you have a whole number added to the fraction or subtracted from the fraction. Now we have some problems that we could use these proportions to solve. And so before we look at that, it says here first you must read the problem, use a variable to represent the unknown, set up your proportion, then drop units and apply cross product principle, solve for x and answer the question. So 4 steps there. And so that we're going to look at some different examples where we can use this. And it's not limited to that, but just that your book have these as some examples. All right, so there are many other ways we could use this proportion. So on page 326 of your book, they're looking at property tax. Okay, so the property tax on a house with an assessed value of $480,000 is $5,760. Determine the property tax on a house with an assessed value of $600,000, assuming the same tax rate. So once this tax rate is same, now in some places your tax rate varies according to the value of a house, but in this particular case, we are assuming the tax rate is the same. So if you know the value of the tax for a house based on a certain value, you should be able to figure out what the tax should be for another house of a different value once the rate is the same. So what we are trying to find is an unknown. So we're going to let it be the tax on the $600,000 house. That's what we're looking for. So what they have done is set up a proportion. So you know that the house that is $480,000 has a tax rate of $5,760. Okay, $5,760 is the tax for a house with a value of $480,000. So that, because the rates are the same, so you're going to put the value of the one that you're trying to find, which is 600,000. So you make sure to line up. If you have the value of this house at the bottom, put the value of the other house at the bottom also. The tax rate is at the top. The tax is at the top here. So the tax should be at the top, but we don't know what the tax is, so we're using a variable to represent it. So 5760 over 48000 is the same as x over 600,000. So they say you could drop the units and just do your cross multiplication. So you're going to multiply 480,000 times x is equal to 5,760 times 600,000. So that's 480,000 is equal to, what's this? 3,456,000,000. So that's when we do the multiplication. And so to find X, we're going to divide this 3,456,000,000 by the 480,000. And once you do that, you get X is equal to 7,200. So you could finish off by answering the question. You don't just stop at X because the question didn't ask you for X. The question asked you to determine the property tax on a house with an assessed value of 600,000. So you finish off by saying the property tax on the 600,000 house is 7,200. Okay, so that's your procedure for using proportions to work out tax value for a house. So that's just one type of example that you could use it for. So let's look at this checkpoint. Let me see, Miss Fernanda. Looking at that question, tell me how would you set that up? Miss Fernanda?
Oh, sorry. I didn't know my mic was off. So I would take 500 divided by 250,000.
500.
3,500 divided by 250,000.
Over 250,000.
And then we're trying to find out, I guess, it says it's an assessed value of 420. So we would say X over 420.
Okay, 420. Okay, right.
Now,
Of course, you know, I was just doing it in interest of time, but normally we'd start off by saying, let X be the tax on the $420,000 house. Then you set up your proportion, then you solve. But in the interest of time, I'll get straight to the point. So now, the next step then is to do your cross multiplication.
okay, so that's 3,500 times 3,500 times 420,000. That'll give me
250,000x equals to 3,500 times 4,200. Okay. So 250 is equal to, when you multiply the 3,500 times the 420,000, what do you get?
looks like 1,470,000,000. So I
470.
have like a million zeros.
Okay, so you have
So that's
1,470.
1,470,000,000.
How many
So that's
zeros that is?
billion.
How many zeros
7
after the
zeros.
Oh, sorry,
7 zeros?
7.
1, 2, 3, 4, 5, 6, 7. Okay. Okay, so that's 1,470,000,000. All right, so that means X then would be equal to 1,470,000,000 divide by
250,000.
250,000. So X is equal to
5,880.
5,808.
880. 880.
Oh,
Mhm.
okay. $5,880. Okay. So you finish out by saying the tax rate for a house of value. 420,000 is $5,880. Okay. All right. Okay. Okay. So now another type of application for proportions is persons who want to estimate populations. So in this case, we are looking at biologists who, what they do is, it says they catch, tag, and then release animals into the wild. And then later on, they go back and observe samples of these animals. And they look to see how many of the ones that they observe are tagged. And based on the kind of ratio they observe compared to what they tag, they can make an estimate of the population. Okay, so you'll see here, they want you to find out how many deers are in the refuge. So what they did, they caught 135. They put a tag on them, and then later on, they observed 140 of them, and of that 140, only 30 of them had a tag. So the 135 had a tag that they sent out, but they don't know how many deers are in the refuge. So this X is representing the amount of deers that are in the refuge. But they know they tagged 135. So if after 2 weeks, I spotted 140, and of that 140, 30 had a tag on them, I could use this ratio now to kind of see if I could guess how many deers are in the refuge. So, okay, so they put the 135 over the unknown amount. We don't know what the total is, but in my amount that I observed for 140, and 30 had the tag on them. So you do your cross multiplication, 30x is equal to 140 times 135. And we continue dividing and multiplying, or multiplying and dividing, I should say. So 135 times 140 give me 18,900 equals 30x. So x would be equal to 18,900 divided by 30. So x is 630. So we're not given an exact amount here. This is an approximation because we're just going based on our observations. So they're estimating that there are 630 deers in the refuge. Okay, so that's one approach that proportions can be found to be useful in making estimates. So I wanted to look at this one. All right, so they say it's a similar type question. They catch, tag, and then release 120 deers back in the wildlife. 2 weeks later, they observe a sample of 150, 25 which are tagged. Assuming the ratio of tagged deer in the sample holds for all the deer in the refuge, approximately how many deer are in the refuge? So I wanted to start jotting down your approach to that, and then look at it. Give you 30 seconds. Okay, so let me see now. Who do I have next? Okay, let me see. Miss Nairn? What you did?
Okay, so it did 120 over X equal to 25 over 150. And
Mhm.
then I said 120
Okay,
multiplied
now,
by,
before you get there, the 120 is the amount that you tagged. Okay. And X is the amount that you're trying to figure out how many in the pop. Okay. And the 25 is the ones that you observe the tags on and you are sample. Okay. All right. Yeah. So now you do your cross multiplication.
yes. So 120 multiplied by 150 equals to 25X. So that's 18,750 equal to 25X. And then 18,750 over 25 equal to X.
Mhm.
And X is equal to 750.
Okay. So you would say we estimate approximately 750 there to be in the refuge. Okay. All right. So we don't stop here. We simply put a sentence for answer to say that we approximately 750 there are in the refuge. Okay. So now on page 327 of your book, you will see where they mention about some types of equations which have no solution. So sometimes we do have some erroneous type of equations. So you'll see this as an example here. They give you this equation 2x plus 6 is equal to 2 open brackets, x plus 4 close bracket. And so when you try to simplify this, you end up with 2x plus 6 equals 2x plus 8. So in simplifying this, you end up with a situation where they put 6 equal 8, but let me see something here. If I was to go on this side, you could have 2x minus 2x equals 8 minus 6. I put the 2x's, and when you subtract here, you get 0 equals 2. So 2x minus 2x is 0. So you end up with 0 equal 2, or in this case, they end up with 6 equal 8. So anytime you end up with something like this, this is an equation that has no solution. Okay. When you're trying to solve, you're supposed to end up saying x equals some value. So right here, they already figured out that this 2x will cancel out that 2x. So that's why they have the 6 equal 8. But if you were to continue trying to bring the terms to the variables on one side and the constants on the other side, you're going to end up with something like this: 0 equal 2. All right. So you end up with a situation where the x's are canceled out, and so there's no solution for x. All right. So it's a false statement that you end up with. So anytime you end up with those kind of false statements, then it says the equation has no solution. The solution set is the empty set for equations like this. Now, you're not going to get too many of these, but in case you do get it, then you will know that that's what the situation is. Then we also have situations where the equation has an infinite number of solutions. So in this other example, you end up here, okay, you get this 4x plus 6 is equal to 6x plus 1 minus 2x. So when you expand it, you get the 4x plus 6 equals 6x plus 6 minus 2x. And when you simplify, you end up getting the same thing on the two sides. 4x plus 6 equals 6x, 4x plus 6. Okay, so if you work further, if you cancel that and that, you end up with 6 equals 6, which is a true statement, but you weren't able to work out the value of x. All right, you were just working out that 6 equals 6. Or if you were to go further, you could have said 4x minus 4x equals 6 minus 6. So that's 0 equals 0, which is also a true statement, but it still doesn't tell you what x is. So when you get this type of result, when you're trying to solve an equation, then you, in this case, this equation have an infinite number of solution, and it's true for all real numbers. Okay, so any number that you put as a value for x would give you a true statement in this case. So you have, in this case, what they call equations with infinite. And again, you won't see many of these in your test or your exam, but in case you come across that, you know that that's a case where this has an infinite number of solutions. So I'm not going to look at those two checkpoints. I'm just going to move on to do section 6.3. Now in section 6.3, we are continuing to look at algebra using equations to solve word problems. And they give you a 5-step process. The first step is to read at least twice. Okay, and they suggest that you put the problem in your own words and try to use a variable to represent one or more of the unknowns. Okay, and then if necessary, write expressions for any other unknown quantities in terms of the variable that you're using. Then you're going to write an equation, solve the equation, and answer the question. And then you could check your answer to see if it is correct. Now, in terms of algebraic translations to English, because we're solving problems, of course, you should be familiar with some of these words here. Some of them mean addition. So anytime you see sum, more than, increase, and so on, that's addition. Some other words for subtraction: minus, decrease by, subtracted from, difference, less than, fewer than, often implies subtraction. Then you see words like times, product, etc., meaning multiplication. And of course, the last column is showing you some of the words that imply division. Okay, so in the little study tip that they give here, it says there's a great value in reasoning through a word problem. A lot of us don't like to do word problems, but the value comes from problem-solving skills that are attained, and is often more important than the specific problem or its solution. So the greater value of being able to solve these type of problems is the development of problem-solving skills. Okay, and so that's the whole aim of it, and help us in dealing with some real-world problem solving in our everyday life. So on page 332, you'll see some other terminology that can be useful to, help us to figure out what a question is asking us to do. And so they give you some examples of some statements that refer to the different types of operations. Okay, so I'm not going to look at that too much. You'll get this to look at later. Okay. All right. So in the study tip here that's shown, they're suggesting that you cover the right column in the table. So this is table 6.2. The last part is here. Cover the right with a sheet of paper and attempt to formulate the algebraic expressions in the column on your own. Then slide the paper down and check your answer. Work through the entire table in this manner. So that's a really good exercise you can do on your own. Cover the right-hand side and see if you could write the statement that is described in the section that says English phrase. And you could do that a couple times to make sure you get the principle. Okay, so that would be a helpful exercise you could do on your own. Also, the next study tip, it says here are 3 similar English phrases that have very different translation. 7 minus 10. Okay, now 7 take away 10. 7 less than 10. A lot of times people get that confused. 7 less than 10 is 10 minus 7. 7 is less than 10. Okay, so just making sure that we understand that even though all 3 kind of indicates a subtraction, the order in which we place the numbers vary according to how it's worded. Okay, so they ask you to think carefully about what is expressed in English before you translate it into the language of algebra. Okay, so we have a scenario here where we are trying to solve a problem. Let's see what the problem is saying. It's saying that the graph in figure 6.4 shows the average yearly earnings in the United States by highest educational attainment. So we have, let's see, less than 9th grade. Then we have, so we are showing you different levels. Some high school graduate, some college, associate degree, bachelor's degree. So as you increase your level of education, they're suggesting here that your earnings go up. So the persons who have a bachelor's degree earn more than the persons who just had 9th grade. Now, looking at the graph, you notice that there are 2 colors. What are the 2 colors indicating?
Pink and yellow.
What do they indicate?
Oh, sorry. Female and male.
Okay, female, male. And you will see that, let me see, as you go through that, it seems as if in every instance, there's one gender that seems to be earning more than the other. Which gender is that?
Male.
Like male.
Okay, so in all cases, it is showing that the males are earning more. Okay, all right. So the average yearly salary of a man with an associate degree exceeds that of a man with some college degree by 3,000. So that's what they're saying. I'm reading the section here. The average yearly salary of a man with a bachelor's degree exceeds that of a man with some college degree by 41,000. Combined, 3 men with each of these educational attainments earn 188,000. Find the average yearly salary of men with each of these levels of education. All right, so that's the problem they want you to solve. So they give you some figures and they want you to work out the average yearly salary of men with each of these levels of education. So let X represent one of the unknown quantities. And if you look on the left-hand side here, the study tip, it says modeling with the word exceeds can be a bit tricky. It's helpful to identify the smaller quantity, then add to this quantity to represent the larger quantity. For example, suppose that Tim's height exceeds Tom's height by 8 inches. Tom is the shorter person. If Tom's height is represented by X, then Tim's height would be represented by X plus 8. So when you have multiple unknowns, the suggestion is that if you can identify whichever is the smallest, use the variable to represent that smaller one. And then from that, you can write statements to represent the larger amounts. Okay. And so here in the solution, they're asking you to let X represent one of the unknown. We know something about the salaries of men with associate degrees and bachelor's degrees or more. They exceed the salary of a man with some college by 3,000 and 41,000 respectively. So we let X represent the average yearly salary of a man with some college in thousands of dollars. So that's what X is representing here. All right. So some college would be this one here. Okay. So moving on. Represent the other unknown quantities in terms of X. Because a man with an associate degree earns 3,000 more than a man with some college, then X plus 3 would be used to represent the average yearly salary of a man with an associate degree. Because a man with a bachelor's degree earns 41,000 more than a man with some college, then you say X plus 41 would be that person's average yearly salary. So we can now write an equation because we know that the person with some college degree, which is X, plus the person with an associate degree, which is X plus 3, which we have up here, and the person with a bachelor's degree, which would be X plus 41. Altogether, they earn 188,000 based on what the question tells us right here. Okay. So that's where we got that 188 from. So if you add them up together, X plus X plus 3 plus X plus 41, you get 188. So combine all the like terms together, that would be 3X plus 41 and 344 equal 188. So 3X is 144. So X would be 144 divided by 3, which is 48. So the average yearly salary with some college is equal to 40X, which is equal to 48. The average yearly salary with an associate degree would be X plus 3, which would be 48 plus 3, because we worked this out to be 48, and he earns 3,000 more. And then the average salary with a bachelor's degree would be X plus 41. So since we got X to be 48, then it'd be 48 plus 41, which would be 89. And so you could now answer your question. Men with some college degree get 48,000 per year, average. Men with associate get 51,000 per year, average. And men with bachelor's degree earns $89,000 per year, average. And you could always check your answer by substituting into the question and see if it works out. So it's a long process, but it follows the basic algebraic principle of reading, letting a variable represent the unknown, writing statements based on what we know, and then writing an equation and solving the equation. So we're going to look at the same principle. Now, this time we were looking at the women. So it says the average yearly salary for a woman with an associate degree exceeds that of a woman with some college degree by 3,000. The average yearly salary of a woman with a bachelor's degree or more exceeds that of a woman with some college degree by 23,000. Combine the three with each of these educational attainments earn 134,000. Find the average yearly salary for a woman with each of these levels of education. And we're using the salaries illustrated in the bar graph on the previous page, which would be this one here. Okay. So who of the three that we have here, who earns the least amount?
Some call it.
Okay, the average years of a woman with associate degree. We have associate degree. That's the first one. And then we have some college. Some college. What else we have? Let me see. The associate degree, some college, and then we have bachelor's. Okay. So some college, you say, so we could say let X represent, remember. So X would represent some college. Okay, so if X represents some college, the associate degree would be represented by what?
X plus 3.
X plus 3. Okay, X plus 3. And then the bachelor's degree.
X plus 23.
Okay, equal X plus 23. All right, so we have the three different levels then, and based on what the question is saying, they give you the total amount that all three earn. What and what's that amount equal to?
134.
Okay, so we could write our equation then as X plus 3 plus X plus 23. So the first group of person here, the second group, the third group, and all that's equal to 134. All right, so work out what X should be then.
3x.
3X.
And then we're gonna plus the 23 equals to 134.
But you have another number here apart from the 23.
What I miss?
You said 3X plus
23.
Remember, we have a 3 and we have a 23.
Oh, so plus 3 plus 23.
And that's equal to 134.
34.
So 3X.
3x equals, so now 3, let me see. So we'll say 3x equals, can I bring it over? I guess I'll 134 plus the minus 3
What
and
is 3?
minus 23.
Okay, what is 23 plus 3?
23 plus 3 is 26. So
That's minus the 26.
134 minus 26.
So 3X is equal to
108.
Okay, 108. So X would be equal to 108.
Divided by 3.
X equals
36.
36. Okay, so if X equals 36, then what can we conclude from there? Or can we conclude from there? Hmm?
That's the average yearly salary of, I guess, each woman.
Which one of them? Remember, we have three categories. We have some college, associate, bachelor's.
So the one that's closest to it,
So which one would the
that would
X?
be bachelor's.
Remember, see, we have X here, some college. We have associate X plus 3, and we have bachelor's X plus 23. So this X, which is 36,000, would be for which one of them?
Is it some college?
Some college. Okay. So some college. I mean, we should write a sentence, but I'm just gonna be brief here. Would be 36,000. Then associate degree then would be what?
36,000 times 3.
Times? It wouldn't be 10. What do we have up here?
Oh, 36,000 plus 3.
Okay, so that would be 36,000 plus 3,000, which gives you
39,000.
39,000. And then the bachelor's degree then,
That'll be 36,000 plus 23,000.
36,000 plus 23,000, which gives you
59.
59,000. Yeah. Okay. Okay. So that's how you would set that up. All right. Okay, so now, let me see. All right, so we have another scenario now where they're looking at, so these problems are a little longish. Okay. So let's see. Researchers have surveyed college freshmen every year since 1969. Figure 6.5 shows that attitudes about some life goals have changed dramatically. Figure 6.5 shows that the freshman class of 2006 was more interested in making money than the freshmen of 1969 had been. In 1969, 52% of first-year college men considered being very well off financially essential or very important. For the period 1969 through 2006, this percentage increased by approximately 0.6 each year. If this trend continues, by which year will all male freshmen consider being very well off financially essential or very important? Okay. All right, so you have a graph here. And of course, again, it has two colors. Okay, one color for women, one color for men. And being very well off financially is what we have on this section here, the first 4 bars. So this first bar is showing you 1969, and the blue for men, 52% believe that being very well off financially was most important. And in 2006, 75%, according to the information at the top here, feel like being very well off financially was most important. So the question is saying to you now, it increased by 0.6 each year. If this trend continues, by which year will all male freshmen consider being very well or financially essential or very important? Okay, so if we are looking for all, what percentage would all be? What percentage is all?
Is it 100?
100%. So in 1969, it was 52%. In 2006, it was 75%. So we want to find out when will it be 100% if the trend continues. And what is the trend? How much is it going up by each year? According to the question, what is the yearly factor?
10?
10? Where you see the 10?
Oh, I'm sorry. No, I just was looking at the graph on the side.
Oh, that it's in the wording of the question.
Oh, okay.
It says this percentage increased by approximately something each year,
Oh, 0.6.
0.6. So it's going up by 0.6 each year. So they want to find out if it continues with going up by 0.6, when will it get to 100%? So they ask you to let X represent one of the unknown quantities. We're interested in the year when all males, freshmen, or 100% of men will consider this life objective essential or very important. So it says, let X equal the number of years after 1969 when all male freshmen will consider being very well or financially essential or very important. So represent the other unknown quantities in terms of X. Okay, there are no other unknown quantities defined, so we could skip that step. Write an equation in terms of X that models the condition. So in 1969, it was 52%. Okay. It increased by 0.6 per year. And we want to get to 100%. Okay, so 52% was the starting point in 69. We're going up by 0.6 and we want to get to 100. So we're going to solve that equation. 0.6, 52 plus 0.6 equals 100. So we end up with 0.6 equals 48. 0.6x, that is, equal 48. So x is equal to 48 over 0.6, x is equal to 80. So they are saying it's going to take 80 years after 1969. And 80 years after that, if you add 80 to 1969, they have estimated here 2049. Okay. So this is an estimate. It doesn't mean that it will necessarily happen because things change and people's perspectives change, depends on world events. But just based on the trend, strictly the trend that we're seeing, then this is the estimate of when all males will see being well off financially is important or essential. And you could always check your answer to see if the answer you get gives a true statement. Okay. All right, so we're going to use that same scenario now to look at, let's see now, it says, shows the freshman class of 2006 was less interested in developing a philosophy of life. Okay, so they're looking at this other one here on this side. So this person was being well off financially, this side is developing a meaning philosophy of life. So in this one, they're focusing on the women. So it says in 1969, 88% of women considered this objective essential. Since then, this percentage has decreased. Okay, so it hasn't increased, it has actually decreased by approximately 1.1 each year. If this trend continues, by which year will only 33% of female freshmen consider developing a meaningful philosophy of life important or essential? Okay. So looking at our starting point, what's our starting point? What year?
1969.
69. Okay, for women, what was the percentage at that time?
88.
88%. And what's happening each year? Is it going up or going down?
Going down.
And what is the rate at which it's going down by?
1.1.
1.1. And we want to find out when it will get to what point?
When it'll get to 33%.
Okay, and it will get to 33%. So that point that we're trying to find out, we could let that point be X.
Yeah.
Okay, all right. So X will equal the time or the period. They ask you if this trend continues by which year. Okay, so the time to get to 33%. Okay, so basically then, based on what you know, how could you arrange this formula? What are you trying to? What's your starting point again, you said?
1969, 88%.
Okay, so we're at 88%.
Okay.
Oh, I guess we don't need the 88%, but and then what's happening each year?
It decreasing by 1.1.
Okay, so we have 1.1x to get to
33.
33. Okay, and so you say we are going down. So if we're going down, what we're going to do? What does a decrease imply? What
Subtract.
operation? Okay, all right. So we're going to be subtracting. So right here. Okay. So we don't need to put the percentage in here, but for now, I'll just have that. So we're going to say 88 minus 1.1x is equal to 33. So how are we going to maneuver this equation?
So are we going to say 1.1x is equal to 33 plus 88?
Okay, see what we have here?
33, okay, negative 1.1x equal to 33 minus 88. Okay, so then it'll be negative 1.1x is equal to negative 55. Negative 55 over 1.1.
1.1.
negative 1.1. And x is equal to 50.
50. Okay. All right. So it will take 50 years.
Right.
So if we are starting at 69, when will 50 years be from 69?
That's 2019.
19. Okay. Okay. All right. So of course, I was just focusing on the mechanics of it, the actual algebra, but when you get a question like this, you're going to finish off by actually writing a sentence to say if this trend continues, what year? You'll say it will take 50 years or until 2019 for a female freshman to consider developing a meaningful philosophy of life essential or very important. Okay. Of course, again, this is another one that would be a kind of speculation based on the trend, but things happen that cause persons, focus to shift. But this is just based on a trend that was noticed. Okay. Okay. So in this case here, we are looking at well, they refer to it on page 355 as choosing between two different long distance plans. And so here you are looking at, it says plan A has a monthly fee of $20 and a charge of 5 cents per minute for all long distance call. Plan B has a monthly charge of $5 and 10 cents a minute for all linked distance. For how many minutes of long distance calls will the cost for the two plans be the same? Okay. So basically, you can write each of those scenarios in algebraic form, and then you will put an equal sign between them, just because you're trying to find out what point the two will be the same. So for plan A, it says it's $20. So you see 20 here, and 5 cents per minute. That's 5 cents a minute right here, 0.005. For plan B, it's $5 and 10 cents per minute. So that's 5 plus 0.10x. So we have plan A on one side, plan B on one side, and we simply going to solve to find x. And right here, based on the calculations that are shown, they're showing that it would take, in this case, 300 minutes before the two plans actually cost the same. Okay, so that's another scenario that we could use in terms of practical applications of algebraic equations. So let's look at this one here. I'm not going to go through this. I just wanted to look at it and tell me how you would set up your equation to find how many minutes it will take for the two to be the same. So plan A is $15, 8 cents per minute. How would you write that in algebra form? Plan A.
You'd say 15 divided by 0.0.
Say that again.
$15 divided by
$15.
0.08x.
Why you say divide? It's 8 cents per minute. So if you have to pay 8 cents per minute, would you be dividing or multiplying?
Sorry, multiply.
Okay. So you have to pay a $15 charge plus you have to pay 0.08 per minute. So that's 0.0x. Okay. Now for plan B, based on what they're saying here, how is the charge? Plan B?
That's $3
$3.
plus 0.12x.
Okay. So to solve that, then they want to know when the two will be the same. So you're simply going to have an equation 15 plus 0.08x equals to 3 plus 0.12x. And you solve that equation. But in the interest of time, I'm going to skip that. We just want to know what the procedure is to set up your equation. You go from there. Okay. Here, we are looking at a scenario where you are given a certain price and then there was a reduction, and we want to find out what the price was before the reduction. So it says here, your local computer store is having a terrific sale on digital cameras. After a 40% price reduction, you purchase a digital camera for $276. What was the camera's price before the reduction? So you're trying to find what the original price is. So in this case, we're going to let X represent the original price. That's the price before the reduction. So the unknown quantity is represented by X. We don't have any other quantities. We're only trying to find that one quantity. So we're going to write an equation that models the condition. So the original price minus 40% reduction gives you 200.
Ready?
Okay. So the original price was X, and you take out 40%. 40% is 0.4. So you take out 0.4x and you get 276. Please note here, if this study tip, it says observe that the original price X is reduced by 40%, which is X minus 0.4x and not X minus 0.4. So there's a difference between these two. You're taking out 40% out of the original price, not just 40%. So make sure in questions like this where you are actually reducing or trying to find what the original price was, if you know how much the percentage that was taken out, that percentage must be taken out of the original price, in this case, which was X. And so once you set it up in this form, then you could go ahead and solve X minus 0.4x is equal to 276. X minus 0.4x gives you 0.6x. 0.6x is 276. Remember now, this is just like 1x. So if you take away 0.4 from 1, you get 0.6. And so you divide both sides by 0.6. So X would be equal to 460. So this is saying that the camera was $460 before the reduction. And you could always check your answer here. Since it was 40% reduction, take out 40% out of 460 and see if you get an answer of 276. And that's what they did here. They found 40% of 460 and subtracted from it. 40% of 460 is 184. And when you take away the 184 from 460, you get 276. So it proves that the price was 460 before the reduction. All right, so look at this question here. It says that after a 30% price reduction, you purchase a new computer for $840. What was the computer's price before the reduction? How would you write the formula for this one? Ms. Nair? Ms. Nair, are you with us?
I'm here.
Yeah.
So what it after 30% price reduction.
Mhm.
Yeah.
So what was the original price? What you're gonna use
So
a
that'll be
variable for that?
X,
Okay, X. Mm-hmm.
X, minus
Mm-hmm.
30% equals 840.
Okay, now is it 30% or 30% of X?
Or 30% of X.
Okay, so minus 30% of X is equal to
840.
840. Now, how could you shorten the 30% of X? When we did this other one, we shortened the 40% to 0.4X. So how could you shorten this 30% of X?
So then it'll be 0.3X.
Okay, so X minus 0.3X is equal to 840.
Mhm.
Now remember, this X is the same as 1X. So if you subtract 0.3X from 1X, what do you get?
So that would be 0.7.
Okay, so 0.7X is equal to 840. So it means then X is equal to
840 over 0.7.
mhm,
X is equal to 1200.
okay. So what does that 1200 tell us?
So that tells us the original price was 1200.
Okay, so you would finish off by saying original price was $1,200. Now, how can you prove if that this answer is correct, Miss Fernanda? Miss Fernanda, you there? Miss Fernanda.
I guess we could say 840 multiplied by 30%,
Is 840? What's the original price?
1200.
Okay, so you took the 30% away from the 1200. So if you took the 30% away from the 1200, that's when you should get 840. Are you following?
Yes.
Okay, so you have to find out what is 30% off 1200.
Oh,
And
okay.
once you find that out, you take it away from the 1200, and then that should give you the result.
So 30% of that is 360.
And
So
360.
when we subtract 360 from 1200, we get the 40.
Right. So that shows then that your answer is correct. Yeah. Okay. All right. So the last part to this is so we all along we are trying to solve for the value of a variable, but sometimes in algebra we don't necessarily need to find a constant or a number value for the variable. Sometimes we need to just solve for a variable, which means we want to rewrite a formula in terms of one of the other variables in the formula. Okay. So on page 337, you'll see where it talks about solving formula for one of its variables. So this formula here is the formula for finding the perimeter of a rectangle. Yeah, P equals 2L plus 2W. So here they ask you to solve for L. Okay, solve for L. So they're not asking you to work out the actual number value for L here. They just want you to write this formula over so that L is what we often call the subject of the formula. Or in this case, you are solving for L, solving a formula for a variable. So basically what we have to do is rewrite the formula now. They have it set up in such a way that they write it as if they're solving a regular equation. So you're trying to solve for L. That's what the question asks you to do. Solve for L. So you're going to move the 2W. The 2W was plus, so it's going to subtract. So if you subtract 2W from the two sides, then you're going to end up with P minus 2W equals 2L. And then we want to move the 2 from the L. So that's a multiplication, so you're going to divide. So you divide both sides by 2. And so now you end up with L by itself. So you could say L is equal to P minus 2W over 2. Okay, so that's one approach. Now, there are other ways you could do it. So I'm going to show you another approach you could use. P equals 2L plus 2W. So if you want to solve for L, which is here, and L is on the right-hand side, some persons prefer to just change the formula around to 2L plus 2W equals P. So all we do is change the order around. And then, since we're trying to solve for L, we could say 2L equals P minus 2W. Okay, so we're going to move the 2W onto the right-hand side. And of course, it would be the opposite operation there. And now we have the 2L. So we want to just solve for L. So you say L, you have to divide by 2 equals P minus 2W over 2. Okay, so that's another approach we could use to get the same result that we have right here. So we're not trying to actually work out a number value or solve the equation. All we want to do is to rewrite the formula so that we have L as the subject of the formula, or solving this formula for L, and that's it. So let's try the same thing for W. We want W to be the subject. So if we write it over, 2L plus 2W equals P, so we just rearrange it. What would be the next step? Ms. Nairn, you could go ahead.
So I could say 2W
Mm-hmm.
Is equal to P
Mm-hmm.
minus 2L,
Mm-hmm.
and then W is equal to P minus 2L over 2.
Okay, very good. Yeah. All right. So we have rewritten it now using solving for W. Now I have another one. I'm not going to look at the example. I'm going to just go straight to this checkpoint. See if you could figure this one out. So it's T equals D plus P M, and you want to solve for M. So let's follow that same principle. We want to make M solve for M. So what do we do first?
Then we say PM is equal 2.
Well, let's rewrite the whole thing so that the PM is on the left-hand side.
Oh, okay. Left hand side. So then it'll be T.
Well, what I was suggesting, you see this D
Uh-huh.
plus PM equals T. So all we did was just reverse it so that it's the same
Oh.
formula, but we just reverse it.
Oh,
So
okay.
now that we have it like this, it's easier to work with. Mhm.
Oh, okay. So then
Yeah.
it'll say PM is
Mhm.
equal to T minus D.
Mhm.
And then M is equal to T minus D over P.
Mhm. Very good. That's it. Yeah. So when you have to solve for a variable, sometimes it's helpful to simply rearrange the formula with the term that you want to solve for on the left-hand side, and then you could write the side that's on the left-hand side over on the right. And once you rearrange it in that form, then it works out less steps in terms of solving for the variable. Okay. So that's basically it. It's a little long. Now you're supposed to do a test. I'm going to send the test to you by Monday. Test based on what we have done so far. This is take home, so but it will be covering all of what we did since the midterm to today's class. And so your homework is here. These are the questions. Page 2 to 8. I have the questions here. For section 6.3, we have 3. This banana. Oh, yeah.
I'm sorry, I have a situation. I saw that outside.
Okay.
Sorry about
Okay.
that.
All right. So for 6.3, these are your questions, and I have the questions shown here. And of course, at the end, you have the answers for the questions. If you did any of the homework, please send it to me so I could give you credit. And your answers are here, so you should be able to check to see if you're on the right track. But if I don't see it, then I won't be able to give you any credit for doing it. Okay. So that's it for today. And all being well, we should see you next week, and I'll send the next quiz or test to you by Monday. Please print it, write it, the answers on the printed copy, and try your best to scan it back or send a very clear copy. So it will be easy when I mark it for you to see the markings. Okay, so that's it for me today. Bye-bye for now.
Thank you. Good afternoon.
Okay, bye-bye.
Okay, good.
Okay.
Afternoon.